Hi, I'm Hanyu, and this is my tutorial video. So, for in this lesson, we are going to solve this question from A to G. So, just begin. So, for the part A, we need to choose three non-zero points and use the three non-zero point to create the vector parametry and Cartesian equations. So for the three non-zero points, let's say just choose 2, 5, -4, and 3, 6, -5, and 4, 13, and -10. So this is the 3 points that we have. So the first thing we should, so at first, I'm going to find the vector equation because it's easier compared to the other two. So at first, I need to choose a point for the vector equation. So I can choose 2, 2, 5, -4 for my point. So the next we should do is to find two direction vectors because it's plane, which means it has two direction vectors. So to find the direction vector, what we need to do is to use this 2 points to minus this point. So let's start. First, we use a 3, 6, -5 to minus this. So it's 3, 6 minus 2, 5, -4. And then we got 1, 1, -1. So for this vector is our the first direction vector, and the next is the second direction vector. We can use 4, 13, -10 minus 2, 5, -4. And then we get 2, 8, and -6. And after factor, we got 1, 4, -3. So it's the second direction vector. So that we got 1 point and 2 direction vector. And then we can write down the vector equation. It's 2, 5, -4 minus s 1, 1, -1, and minus t times 1, 4, -3. So the next we should do is to get the parametric equation. So we have x, y, and z. So for the x is the 2 minus s minus t, and y is 5 minus s minus 4t, and that is -4 minus s minus um plus s and minus 3t. So the next thing, so then we need to find the uh, Cartesian equation. So for the Cartesian equation, we know that its format is ax minus by plus c z plus d equals to 0, and a b c is the normal vector for for the plane. So to find the normal vector, we can use two direction 1 1 -1 and 1 4 -3 to get the normal vector. We use the one we use cross product to get the normal vector. So it's so after calculate, we find the normal vector is 3 plus 4 1, and negative times 1 minus plus 3 is 2, and 4 minus 1 is 3. So this is the normal vector for the plane. And so that we got a is 1, b is 2, c is 3. So then we need to solve for d, and for d we can just use the points we create at first. Let's just use 2 5 -4. So it's 1 times 2, it's 1 times 2, and plus 2 times 5 minus 3 times 4 plus d is equal to 0. And then we got d equals to 0. So for the Cartesian, we can find that it's x minus 2y minus 3 that equals to 0. So we got the vector equation, which is that, and we got the parametric equation, that, and we got the Cartesian equation. So we solved for, so we have successfully solved A. So then we need to let's look at question part B. It says create a Cartesian equation for plane parallel to the one from part A. So we can, like, in the R cube space, um um, a Cartesian equation of a plane that's parallel to another plane is that they have the same A and the same B and the same A, but the D is different. So it looks like that whatever. So for plane parallel to another plane, for the Cartesian equation, the only difference is the D. The only difference is the D. So we will just use the Cartesian equation from part A, which is x minus 2y plus 2y plus 3 that, and we just need to add a different D for the parts. And in A, the D equals to 0. So let's just use D equals to 1 in this part. So we got the Cartesian equation x plus 2y plus 3 that plus 1 equals to 0. It's an answer for part B. And let's see part C. It asks us to find a Cartesian equation for planes that coincide with the one from part A. So like in a R-cube space, if a plane is like that, so for another plane that is coincide with it, the answer for it is like k times the Cartesian equation. So k can be any integer number. So for this part, let's use k equals to 2 to get the answer. So we use 2 to times the part A answer. So the answer for part C is 2x plus 4y plus 6 equals to 0. So this is the answer for part C, that this plane is coincide with part A. And then let's look at part D. It says create a Cartesian equation using the rule below, where A equals to your birth month, subtract 10, B equals to your day of birth, subtract 15, and C equals to -1, D equals to your favorite number. So for the part D, and my birthday is August 27th. So if my birth month subtract 10 is -2, and for B, my day of birth subtract 15 is 12, and C equals to -1. D, let's say D equals to 12. Okay, so we got the two. So we got the A, B, C, D for the Cartesian equation, and so it is negative 2x plus 12y minus d plus 12 equal to 0. So it's the answer for part D. So let's look at part C, part E. It says so for the intersection for the three planes from part A, C, and D, explain what your result means in the 3D space. So for this question, we need to find the intercept of part A, part C, and part D. However, for part C, it says a plane that's coincide with part A. So it means that A and C are the same plane. So so actually we just need to solve the intersection for part A and D. So for part A, our answer is x plus 2y plus 3 z equal to 0. And for part D, our answer is negative 2x plus 12y minus z plus 12 equal to 0. So we need to find the intersection of the two planes. So the way that we can use to find the intersection is that we can say that x equal to t, and then we got that and then we got that 2y plus 3 z equal to negative t, and 12y minus that equal to negative 12 plus 2t. And then we need to solve y and z. So let's say it's a part 1. So then I will solve for d. So let's use 1 minus 6 equal to 12y plus 18 that equal to negative 6t, and we use the and we use 1 minus 2. So we got 12y plus 18 that minus 12 that plus that equal to negative 6t plus 12 minus 2t. And we got 19 that equals to negative 8t plus 12. And so we got z equals to negative 12 over 19. No, the 12 over 19 minus 8 over 19t. So we solve, and then we need to solve for y. So for y, we use the calculation 1. That's 2y plus 3, 12 over 19 minus 8 over 19t equals to negative t. Then we need to calculate for y as negative 19 minus 5 over 19t. So y equals to negative 18 over 19 plus 5 over 38t. So that we got x, y, and z. So let's use parametric equation for that. So x equals to zt and y equals to negative 18 over 19 plus 5 over 38t. Is that equals to 12 over 19 minus 8 over 19t. So this is a parametric equation for the intersection of the two planes. And we can write it into vector equation, which is vector r equals to 0, negative 18 over 19, and 12 over 19 plus t, because the direction vector need to be integers, so the direction vector is 38, 5, and minus 16. So then we got that the intersection of the three plane is this. And as we can say that it's an equation for a line, which means that for the three plane from part A, part C, and part D, the intersection of them is a line. So the graph of them might looks like um that, and the intersection is this line. So it's the answer for part E. So after the question E is question F. It F it says create a vector equation for a line in 3D space using 2 points A, B, C, and D, E, F created, where A, B, C, D, E, F are any positive or negative integer, but not a zero. So for this question, we need to create 2 points first. So let's create. So let's use the points. Let's see. 4, 7, 9, and point 12, 13, and 16. So for this question, we need to find a point and because it requires a vector equation, so we need to find a point and a direction vector of it. To find the direction vector, we can just use this point to minus this point, and we can use one of these two. We can use one of the 2 points to as a point. So let's use the point 12, 13, 16 minus 4, 7, 9. And we got 8, 6, and 7. So it will be the direction vector for the vector. And let's just use 4, 7, 9 as a point. So the vector equation for part F is point 4, 7, 9 plus t times 8, 6, 7. And So that we got the answer for part F. And let's look at the final question. Question part G. So for part G, it says solve for a intersection for a line created from part F is a plane made from part D. So for part D, our answer is negative 2x plus 12y minus 8 plus 12 equals to 0. And for part F, our answer is 479 plus t times 867. So to find the intersection of the line and the plane, we can write the vector equation into parametric equation, which is x equals to 4 times 8t and y equals to 7 plus 6t. That equals to 9 plus 7t. So it's our so the next thing we need to do is we need to put the put this x, y, z into this Cartesian equation so that we can solve for t. So it's negative 2 times 4 plus 8t plus 12 times 7 plus 6t plus minus 8 minus 9 minus 7t plus 12 equal to 0. And then we got negative 8 minus 16t plus 84 plus 72t minus 9 minus 7t plus 12 equal to 0. And 72t minus 16t minus 7t plus 84 minus 8 minus 9 plus 12 equal to 0. And we got 49t plus 79 equal to 0. So t equals to negative 79 over 49. And it's negative 1.612. So it's a t for the intersection. So the next we just put the t into this parametric equation so that we can get the answer we need. So it's 4 plus 8 minus 1.612 equals to negative 8.896. And for y is 7 plus 6 times negative 1.612 equals to negative 2.672. And for z, we use 9 plus 7 times negative 1.612 equal to this way. We write it 9 plus 9, 9 plus 7 negative 1.612 equal to negative 2.284. So we get the answer, the intersection of the plane of the part F and part D is point negative 8.896, negative 2.672, and negative 2.284. That's the final answer we got for part G. And that's all for the tutorial video, and thank you for watching.